Hey guys, today's September 3rd and we're going to be going over polynomials. So today we're going to be learning about different types of polynomials. We have something called a monomial, a binomial, a trinomial, and then just a general polynomial. So we'll first start with monomials. Monomials have one term and they have no addition or subtraction. Next, we're going to talk about a binomial. A binomial has two terms. Bi means two. You have two terms and it has one addition or subtraction sign. Next, we have something called a trinomial. Trinomial means three. This one has three terms and has two addition or subtraction symbols. Okay, and then lastly, we have something called a polynomial. Polynomials are all of these, a monomial, binomial, or trinomial. It only has, it could have all the separate terms and it can have multiplication in between. You are never dividing by a variable, okay? Okay, so now that we have all this typed in, we're going to go ahead and look at different polynomials that we have down here. We're going to go ahead and label the type of polynomial it is, and then we're going to list out its terms. So this first one right here, you'll notice that it says 3x squared. There is no addition and no subtraction. So that means that it cannot be a binomial or a trinomial. It only has one term. If you look at all of this, this all goes together. It is not dividing by a variable, so that means that it is a polynomial, okay? And then we know that it only has no addition and subtraction, so this is what we call a monomial. So inside here, for our type of polynomial, it's going to be called a monomial. For terms, we're just going to list out what we have in our polynomial. So I'm going to go back to my add-ons, and we're going to be using Hypatia today to insert our text. So you'll notice that we have 3x squared. 3x squared is what I actually call my term. Okay, so here we're going to insert 3x squared. So I'm going into my editor. We should know by now how to get an exponent in there. And then you just go ahead and click insert. Remember, it just drops it wherever it wants to in your page. So you're going to have to grab it and move it wherever you need it to go. The next problem is -9. This does not have an addition or subtraction sign. It's just a -9. So this is actually called a monomial as well. Monomial. Now our only term here is the -9, so we're just going to go ahead and write -9. The next one is 1/4 x. There's no addition or subtraction, so it's a monomial, and you'll notice that they're not dividing by a variable, which means the letter is not at the bottom. The letter is at the top, a 4th x. So this is actually a monomial as well. And I'm going to come over here and insert my 1/4 x. Now, because it is a fraction, we will have to use our tools again. So we're going to go back into our insert text. So for a fraction, you're going to have to make sure that you go to x squared and you're going to click a over b so that we can go ahead and put our 1/4 in our fraction form. So 1/4 x, insert, and again, remember to move it wherever you need it to go. Okay, the next one, you have 2x minus 7. You will notice that you do have a minus symbol. There's only one addition or subtraction symbol. It's actually a subtraction. So this makes it a binomial. We have what we call two terms in this problem. So I'm going to type in here binomial. That's the type of polynomial it is. And then for our terms, we have two separate terms. It starts with 2x, so whatever is in front of the addition or subtraction sign goes first. That's what we call our first term, 2x. And then I'm going to put a comma, and my second term is the -7 or the -7 that I have. That 7 has a minus or a negative in front, so we need to make sure to write that out. So our two terms, we have a 2x and we have a -7. That's how we know that it's a binomial. The next one, we have two terms that are put together by one addition and subtraction sign. So there's one symbol here. So again, this one is also a binomial. And for our two terms, we have 3x squared y, that's one term, and then 2z squared. So remember, that addition or subtraction sign separates your terms. So because that addition sign is right here, whatever's in front of it is one term, and whatever's behind it is my second term. Okay, so for this example, we put the 3x squared y was our first term, and then our next term was 2z squared. So I'm going to go ahead and insert that. Again, remember it drops it wherever, and we just move it. Okay, the next polynomial we have is x squared plus 6x plus 9. This one has two addition symbols. So because it has two addition symbols, it makes it a trinomial because there are three terms. So here for our polynomial, we're going to go ahead and type in trinomial. And our three terms are x squared, 6x, and 9. Okay, so because it has the x squared, we are going to have to insert our Hypatia tool for the x squared, and then I'll go ahead and type in 6x and 9 there as well. Okay, the next one we have 9xyz minus 3xy plus 2z. Here we have two symbols, two addition or subtraction symbols, and that makes this a trinomial as well. It is separated into three separate terms. So we're going to go ahead and type in trinomial and list out our terms. Okay, let's look at what I typed in over here for my terms. I put the 9xyz, and then I put a minus 3xy. Remember that symbol has to go with it because it's a minus or a negative. It has to stick with it. And then a 2z. You could put the plus 2z. You don't have to. It's just positive 2z. Okay, the very last one, 3x plus 4 over 2x. You notice that x is at the bottom. When that happens, it is not classified as a polynomial. So here, when it's asking what type of polynomial is it, it is not a polynomial. So not a polynomial. And there are no terms if it doesn't have a polynomial. Okay, let's go over some key vocabulary. Today we're going to be talking about the word degree. Degree is the largest exponent, so the highest exponent in a polynomial, or adding the exponents when more than one variable is given for a term. So here, looking at example 1, the degree is the exponent that we have here. So 3 is the degree, 5 is the degree, 2 is the degree. So that's the highest one that we have. If it had more than one variable, our degree would be adding the polynomials. We don't have that together for today's example, so don't worry about that. Standard form. Standard form is the highest degree is written first, and that's how we're going to write it for standard form. I'll go over that here for example 1. We have what's called terms. We went over that a little while ago. It's the number or variable or product of both. Coefficient, this is the constant or the numeric term before the variable. So what's in the very front of the variable or the letter. And then next we have something called leading coefficient. That is what's at the very front whenever your polynomial is written in standard form. Okay, so here for example 1, simplify the following polynomials. Write in standard form, identify the leading coefficient, and determine the degree. So I went over degree first, so we'll just go ahead and put that here. The degree is your highest exponent. So which exponent is the highest out of the 3, the 5, and the 2? Obviously the 5. So the degree of this polynomial is degree 5. We're going to go over standard form next. Standard form means that you want to put these in order with the highest degree first. So our highest degree is x to the 5th. So that means that whenever I write this in standard form, I'm going to have x to the 5th first. My next highest is x to the 3rd, so plus x to the 3rd. And then the least is minus x squared. Notice that I brought that minus down with it. So this is written in standard form. My exponents are biggest exponent going all the way down to smallest exponent. Okay, leading coefficient. Leading coefficient is what is the front number or number in front of the very first degree. So x to the 5th. There's an imaginary 1 there. So the leading coefficient would just be 1 for this problem. For example, 1. The leading coefficient, the front number is a 1. Okay, example 2. On example 2, if you had to identify the degree first, we'll do that first. You'll notice that you have a 2 as an exponent. You have a 4 as an exponent. There's no exponent here, but because there's no exponent, there's an imaginary 1, x to the first power. So if I have a 1, a 4, and a 2, the highest degree or the highest exponent is a 4. So this has degree 4. Let's go ahead and write it in standard form. So for standard form, you want to put your highest exponent first. So looking at this, I have an exponent with a 4, a 2, and we remember what we said, it's a 1 there. So the 4 is the highest. So we would type in 5x to the 4th. That's the highest degree. So I'm going to cross that out. That's gone. Then the next one would be a 2. That's the next highest degree or highest exponent. So minus x squared. Now that's the next one. Then plus the 3x. And then lastly, this doesn't have an exponent with it, so minus 2. That's at the very end. So this is how I would write it for standard form. And you can go ahead and type that in with your Hypatia tool or write it down in your journal if you're using a journal at home to just write in. But let's go ahead and look at the leading coefficient. What is the very front number when this is written in standard form? The 5 is at the very front. It's in front of x to the 4th. So my leading coefficient is a 5 for this problem. Okay, let's look at the next page. On the next page, we're going to be going over how to add and subtract polynomials. So here it says, simplify the following polynomials, write it in standard form, identify the leading coefficient, and determine the degree here. So first, we're going to go ahead and simplify the polynomial. So to simplify it, you have to get rid of the parentheses. Notice that plus sign, there's always an imaginary 1 in front of that parenthesis right here. So here, there's also an imaginary 1. So everything inside gets multiplied by 1, which means it stays the same. So 4a minus 5. If I multiply everything over here by 1, that also stays the same. So now that I got rid of the parentheses, I can go ahead and combine my like terms. So I have a here that can go with a here. So together that's 7a. And now we put our numbers together. A negative 5 plus 6 makes positive 1. So 7a plus 1. And that's already written in standard form for you. So 7a plus 1 is our standard form. So I'm going to come over here and I'm going to type in SF, stands for standard form, in case you didn't catch that on the last one. So standard form was 7a plus 1. Next, we have to determine the leading coefficient. So I'm going to put LC for leading coefficient. What's the front number? That's a 7. And then our degree. Degree is the highest the highest exponent. So our exponent is a 1. There's an imaginary 1 right here, even though there's nothing written. It's understood to be a 1. Okay, example 4. For example 4, we need to simplify this expression. We got to get rid of the parentheses. Remember, there's an imaginary 1 up here in the front. So with that imaginary 1, everything would be multiplied and just stay the same. So I have 3p squared minus 2p plus 3. Now this one, same process. There's a positive 1, so everything inside over here stays exactly the same as well. So plus p squared minus 7p plus 7. Now we're going to combine our like terms. So we have to figure out, can anything go together? Yes. I could put 3p squared with this 1p squared that I have there. So together we have 4p squared. And now we want to put our p's together. So a negative 2p and a negative 7p. That's a minus 9p. And then we have 3 plus the 7, so plus 10. So this is my answer written in standard form. Notice that the exponent 2 is first, then this exponent has a 1, and then this one doesn't have an exponent. So that's already in standard form for you. So if I were to type this in standard form, we would make sure, whoops, sorry about that. We would make sure that typing it in standard form, we have 4p squared. Now to save time and not have to go back to Hypatia, I'm just going to put 4p. So to save time, we're going to go ahead and put 4p raised to the second. So that little symbol right there means a caret key, which means an exponent. So 4p squared minus 9p, and then plus our 10. Now we also have to determine the leading coefficient. What number is up in the front? That's a 4. And then the degree, which is the highest exponent that we have, which is a 2. Okay, problem 5. On problem 5, you'll notice that we have a subtraction symbol. This changes the problem completely. that minus symbol means that there's a -1 in front of this entire parenthesis. So what that does is it makes that a negative, it makes this a negative, and it makes this last one a negative times a negative. It makes it a +1. So I'm going to rewrite the front part. It's still a 1 in the front, so it's 3x squared minus 2x. That whole thing stayed the same. But the second half of our polynomial became a minus 3x squared, a minus 5x, and a +1. So now that I have it written out, we can go ahead and simplify our polynomial. So 3x squared, we need to figure out 3x squared, take away 3x squared. Oh, that means that there are no more x squared. Okay, so now we move on to -2x and -5x make -7x's or -7x. And then we have +1, so +1. And now we're going to go ahead and type in our answer in standard form, determine the leading coefficient. So I will start with standard form. So standard form, it's already written with the variable first, so -7x plus 1. We have to figure out what's the leading coefficient. The number up front is a -7. And our degree. Do you remember what the degree is if there's nothing written there with the x? It should be an imaginary 1. So there's a degree of 1. Okay. Today you're going to be working on adding and subtracting polynomials. Have a great day, guys.